My Hantek oscilloscope had a fault where all of the rotary encoders were not responding, but the button still worked. In this video I'll show how I discovered the cause and how I repaired the scope. But before the scope can be repaired, it needs to be disassembled. After removing the keyboard from the oscilloscope, I reversed engineered some of it, shown on this schematic. In the bottom corner here, we have the U4 chip, which drives the LEDs on the keyboard. these LEDs light up when different functions are active. Going up, we have this connector, which is a flex cable connector that connects the keyboard to the motherboard. There are some ground and power pins, a clock pin, and a serial out pin. The serial out pin is driven low when buttons are pressed and when encoders are turned. These three chips controls the encoders. U1 is a binary counter that controls these two outer chips. U3 and U2 are multiplexing chips, which are all connected to these encoders. As you can see, all of the encoders are connected to these two rails, which I have labeled U2A4 and U2A6. U2A4 and U2A6 are connected up here. When this fault occurs on the keyboard, what happens is that one of these encoders shorts one of these rails to ground. What happens is that the serial out is driven low when either one of these are active during the multiplexing process. The result of this is that none of these encoders are able to detect any motion, which effectively disables all of these encoders. And again, what happens is that because of a short in these encoders, A or B will be shorted to ground through the encoder and thus pulling either this rail or this rail low. An encoder can be tested with a multimeter in resistance mode. Connect one lead either to the A or B pin on the encoder and then connect the other lead to ground. A low resistance will indicate a shorted encoder. I have already removed the shorted encoder on this board, and the encoder I'm testing is not shorted. I desoldered the shorted encoder by using a desoldering pump and then some soldering wick to remove the remaining solder from the holes. If the holes are mostly free of solder, it makes installing the new encoder much easier. After the faulty encoder has been removed, a new has to be ordered. There are three types of encoders on the keyboard, where some have push buttons, some have detents, and some have both. I have listed the three types of knobs here, where they are used, and their respective product numbers. Alternatives from other manufacturers might also be a possibility. After the new encoder was soldered in place, I reconnected the keyboard to the scope and verified that all of the encoders are now responding. Also, please don't touch any of the mains voltage circuits while the scope is on. Reassembly can then be done by following the teardown in reverse. To help others troubleshoot, I have connected serial out, shown earlier on the schematic, to another oscilloscope while rotating an encoder. If the voltage is not pulled high when an encoder is rotated as shown, one of the aforementioned rails is most likely shorted to ground, possibly by a faulty encoder. When a button is pressed, the voltages dips beneath that of the encoders. Looking at this trace was what eventually led me to the shorted encoder, and it would have been nice to see what this trace looks like on a working scope. So there you go. I hope that this video can serve as a starting point in troubleshooting this fault in these Hantek scopes. Thank you for watching.